In this lecture, we are discussing the third type of the detector, the synchronous or the coherent detector. The block diagram of the synchronous or the coherent detector is that one, that there are two signals. The first one is the modulated signal and the second one is the locally generated carrier signal. Both of them are multiplied and then after that you will use like here the output VIT. The VIT will then be given to the low pass filter, and then from the low pass filter you will end up with your message signal. So message signal is Y of T. The only problem here is that you have to generate the local oscillator, have to generate the carrier at the local position. So it means that you should be very careful in order to use the same phase and frequency of the local carrier. That frequency and phase of this local oscillator should be synchronized with the phase and frequency of the local oscillator that has been used at the transmitter side. So that is the only difficulty here in this case, but otherwise this circuit is a very simple. Like VIT, so you are multiplying AM T and then you are multiplying AC cos omega CT. So what is modulator signal AC? 1 plus mu of MT cos omega CT and then multiplying AC cos omega CT. So that is equals to AC square 1 plus mu of MT and then cos square omega CT. We know that cos square omega CT will be equals to 1 by 2 1 plus cos 2 omega CT. So use the here. So this is AC square 1 plus mu m of t. So 1 by 2 1 plus cos 2 omega CT. So that is AC square by 2. So if you multiply this with that one, so it is 1 plus, if you multiply this with that one, so it is mu m of t, and then if you multiply with this one plus cos 2 omega CT and then plus mu mt cos 2 omega CT. So the frequency of that signal is FM, the frequency of that signal is FC, 2FC, and the frequency of that signal is 2FC plus minus FM. So we have low pass filter whose center frequency is FM, only that signal can pass through there. So it means that we have YT is equals to AC square by 2. It will block this one, it will block this one, only these two signals can pass. So 1 plus mu of MT. So you can see that you will end up with AC square by 2 plus AC square by 2 mu of MT, and then using DC blocker this can even go. So then you can have AC square by 2 mu of MT. So this is the desired signal. So generation using this type of circuit is very easy. Like using the synchronous circuit, the detection is very easy. But only issue in this detector that you have to locally generate the carrier, and the frequency of that carrier and the phase of that carrier should be synchronized with the frequency and the phase of the carrier that was used at the transmission or at the transmitter side. Otherwise this circuit is very easy to use, and we can use this type of circuit for the point to point communication where you have only one transmitter and one receiver. So if we have only one transmitter and one receiver, then it is better to use synchronous detector rather than other detectors. I hope you understand this detector. So if you still have any question, you can write your question in the comment box. Thank you for watching the video.